I'm writing a series of articles on element 14 about very simple control mechanisms, and in this case I am testing a JFET as a current control device. It's an idea coming from the book The Art of Electronics. This is the 3rd edition. It's a very simple setup. It's one JFET, one resistor. I'm not going to go over the theory here in this video. That's in the book and a little bit summarized in my blog post. But I'm going to try and measure one configuration here with a Fairchild J113 N-channel JFET and a 165 ohm resistor. I have set up everything here on a breadboard. I have plugged in 1 meter to record the voltage between drain and source, and 1 meter to measure the current through the drain, and then my power supply, I will go through a number of steps here, through a number of voltages, and measure the results. And let's start with the action. So this is the circuit that I've built up here. Current meter, a LED just for fun, the JFET and channel, and a 165 bias, negative bias resistor. I'm going to provide 1 to 30 volts. I have put a voltmeter over the drain and source. And what I'm going to write down is in this column the current that I measure, and in this column the voltage drain source, all versus the changing input voltage, the power supply voltage that I am going to manually set between 1 and 30 volt. And then in the end I will make a drawing here on the graph to see what result we have. So let's give it a go. The voltmeter is set for 1 volt. It's not on yet, so I measure nothing over the gate source and I measure no current. I'm now going to put 1 volt. Current we measure is nothing, and the voltage we measure is nothing. Let's now set 2 volts. 2 volt. I measure 1.03 milliamps and 36 millivolts. So 1.03 and 0.036. I'm now going to set it to 3 volts.
5.35 milliamps and 242 millivolts. 4 volt, 8.9 milliamps and 530 millivolts.
I am going to touch the JFET to see if it's not heating too much. It's still doable. Then the last measurement is 30 volts. My FET can handle 35, by the way. 13.69 milliamps and 25.78 volt. That's it. Now I'm going to put all those things on the graph. The voltage drain source will be the x-axis and the current through the drain will be the y-axis, and I'm expecting a graph something like this where we see the current being constant after a certain point. So that's it. A small circuit that you can use to control the current through a device. The current is not very precise, but it's very constant over a wide range